候开始录呢？好紧张，不要紧张。欢迎大家来到柴火，我是Elaine，Seed 的负责 Jetson 产品线的市场和生态合作 platform。然后我们今天非常开心的邀请到 Glenn Jocher Ultralytics team， 他是Ultralytics 的 CEO and founder， 然后也是我们现在很熟悉的 YOLO V5 和 YOLO V8 的作者。然后同时我们也邀请到了Paula， 他坐在后面 ，Paula 是 Ultralytics， 对 ，Paula 是 Ultralytics 的负责 Sales and Marketing 的 lead。所以我们今天的活动同时也会在 YouTube 进行直播。然后我们今天的主题是邀请 Glenn 来跟我们分享最新的 Ultralytics 的 product update， 然后还有一些就是 real world YOLO V8 到 YOLO V5 application， 现实世界中现在大家都在用 YOLO 的算法在部署哪一些应用，所以 OK 欢迎大家。我等一下会再用英文再介绍一次 ，in case Glenn 不对，感谢大家。同时我们今天活动非常开心，邀请到很多不同的观众来，我看到有算法工程师有学生，还有哪位是医院的工作者，好像还有六福珠宝的算法工程师，我很 surprised 的，六福珠宝已经有算法工程师了吗？对，所以非常感谢大家到来，我希望这次活动大家可以就是听了Glenn的分享，可以对你们有所帮助。然后你们如果有任何感兴趣的疑问，都可以找到 Ultralytics。如果你们有部署或者是在任何在任何的应用中需要用到边缘设备的，包括一些 microcontroller 或者是 GPU 到 SBC 像树莓派欢迎找到 Seed。我们很乐意去协助你们，帮助完成现实应用中的部署。OK，Frank， 我们在直播了吗？那我就不用开始了，是吗 ？OK，so today we're going to start our session, and I speak by Glenn Jocher, and so he will share with us the real-world application using the YOLO V8, and also he will also share with the latest update for the YOLO, and also the introduction for the YOLO. So YOLO is right now is one of the most popular computer vision model and it is widely utilized by all the developers and the ML engineers. And it supports very wide tasks like object detection, classification, segmentation, pose estimation. So I believe you will also have very new updates aligned with us. Yeah, so give it to you. Yeah, thank you, Glenn.
Okay. Okay, thank you, Elaine, and hello, everybody. So first of all, I wanted to apologize. I wanted to do this in Mandarin, but Elaine said I should do it in English for the international community. So I am Glenn Jocher. I'm the founder at Ultralytics, probably better known as one of the YOLO authors. And I'm here to tell you a little bit about Ultralytics, how we started, and what we did originally, which was very different than computer vision. The problem today that we're trying to solve, a little bit about the YOLO models themselves, because they have a colorful past, and an explanation about what we're doing with them now, and a smart look into the future. So, oh, no, let's do this one. There we go. Okay, so first of all, what do YOLO AI models do? So they're best known for object detection, which is simply spotting something in an image, regressing a bounding box around it, and classifying what the object is. So what we're looking at right now is a video of the YOLO V8 World V2 models that have been single-shot prompted for car brands like Lamborghini, Porsche, and others. And so you can see that these work very well. They can spot the make of a vehicle, they can identify where it is, and they can do this very quickly in real time today, even on mobile devices like your iPhone. So This is really cool, and we're able to do that with a relatively small model compared to what we see in the space. So this plot that we have here goes back over a decade into the recent trends in ML and AI. So machine learning was born way before this. In the 1960s and the 70s, the theory was first proposed by researchers in the United States. And the basic idea was to, instead of processing deterministic ways, to try and reproduce the way that the brain works and humans think with interconnected nodes that essentially transmit information through a combination of weights by multiplying an input and biases summing onto that input. So around 2010, you can see that models were very small. So we have cost and size here on the y-axis. And of course, the trend has been increasing capability, but unfortunately coupled with increasing complexity, and if you're a business, cost. And as we see today, the largest models are off screen at this point, models like GPT-4 that are about 1,000 billion parameters, and this places them well outside the range of individuals and even small businesses to train those models and deploy them. And so to me, that's very sad. Because when I started doing ML, it was around 2020, and it was great because you could buy a cheap GPU from NVIDIA. This is before the stock had exploded. You could plug that into your computer, you could train a small model, get a result, and maybe improve upon it, and you'd create a breakthrough just yourself, and you could open source that. And just as a personal or small organization, you could have an impact on the space. You can see your work contributing to the betterment of society and the advancement of the technology. But not today. Today, if you really want to play with LLMs and the state-of-the-art ones, you're going to need to do that at a large enterprise that's very well funded, which goes against a lot of my values. I've always wanted to take this technology and bring it down to the individual level so that we could have an impact not just as big companies, but as people and as individuals. And this is really the story of Ultralytics today. So today, Ultralytics is about making AI accessible, making it fast, small, and simple, and easy to use. So in comparison to the largest models that are produced today, the largest YOLO models are over 1,000 times smaller, which means that they're also 1,000 times faster to train and cheaper to train. So this means that everybody can still be in the game in the YOLO space. You can still, with a single GPU, train a model, experiment, make a discovery, publish it, and push the field forward just by yourself. So that's really exciting. I like that. So this brings us to our vision for the space. And the vision is really for AI to be a transformative technology in the sense that everybody uses it. And it's accessible to all people in all places, regardless of means and resources. So we don't just want big companies and governments to be able to use the technology. We want everybody, including school kids and anybody that just has a project that they'd like to do. So we work really hard on making our YOLO models trainable with low resources. So cheap hardware, a small GPU, low memory. So we worry not just about deployed performance, but about training metrics. Like when we research YOLO models, we think, is this going to take up more GPU RAM? Is this going to take longer to train? Is this going to make it harder to deploy? And if the answer is no, then we move in different directions. So this is in contrast to some of the open AI companies that you see today who have models that are proprietary. They're not public. And even if they were, nobody could actually run them themselves because they're so enormous. So, okay. So a little bit about how Ultralytics started. I founded the company in 2014. Back then, I was living in Washington, D.C., and I was working on US government programs that were funded by some intelligence agencies. And the idea was that they were interested in anti-neutrino detection. So this was particle physics. This is very advanced particle physics where they wanted to create very small detectors with fast electronics that were able to visualize those particles. And so I came on to simulate those detectors. And then once they were built, I got all the data, and then I had to analyze it. So I became a data analyst. And this is how I started getting into AI. the data analysis on those particles was very difficult using traditional techniques. And I realized that it had really close parallels to computer vision because we wanted to classify the particles. We wanted to know if we were getting a neutrino, a proton, an electron. That's very important. And also where they were coming from. So a direction vector and an energy for the particle, which is just a regression. So when we do YOLO bounding boxes, we're doing the same thing. We're regressing a box, we're classifying what that object is. And so I realized that the particle physics applications translated very well to computer vision, and also very appealing to me. The computer vision space was more impactful. So anti-neutrino physics was really interesting, but it's a bit of a niche field, and it's really what's called fundamental science, which means that it's only funded by the government because there's no business use cases. So it's not going to be in people's hands anytime soon, but I thought, hey, if I can make an impact in the computer vision space, I can really make a change in the world and put that in people's hands. So I pivoted the company to computer vision in 2020. After about 2 years of super hard work, I launched YOLO V8. And that was my first formal attempt at a new architecture. And what had happened was I had started off from YOLO V3. So the YOLO story doesn't start with me. Before I came along, there was a graduate student called Joseph Redman at the University of Washington, and he had an academic advisor called YOLO V8. And so these two made a bit of a breakthrough in the computer vision space. And the breakthrough was that they realized that the state-of-the-art architectures of the day, like faster RCNN, could be simplified. So these architectures that were being used back then, 2015, would take 2 passes through an image. They would look at an image, they would identify regions of interest, and then they would focus on those to classify what was in that space. So the interesting thing is this is similar to how human vision works. We have peripheral vision, and then at the center of your eyeballs, you have a higher density area of rods and cones that's capable of observing something in higher resolution. So typically we'll see something, and then we'll turn around and we'll look at it. 2-step process. And so the models of the day did the same thing, but Joseph realized that, hey, I think I can do this all at once. And that would, by definition, simplify things about 2x. And so YOLO was born. And the acronym here, of course, is You Only Look Once, and that recognizes that differentiation in the architectures. So YOLO would take a look at an image a single time. The image would pass through many convolutional layers, and it would turn from a high width and height image into something that was much smaller in width and height, but was elongated as a feature vector. So those 3 RGB images would turn into something that was about 1,000 features long. And this feature vector contained not just the locations of the boxes, but the classes also. So Joseph followed that up the following year with YOLO V2, which also experimented with additional classes, sometimes called YOLO 9000, which is very interesting for very high class count detection. And the next year, in the final year, 2018, they released YOLO V3. At this point, the architecture had gotten so popular that they got invited to a TED Talk. In the US, it's a popular type of talk that you go to as an academic or as somebody in business. And the talk was so well received that a military officer came up to Joseph and he said, Joseph, this is amazing. You know, we want to use this in some drones on the battlefield. And Joseph thought about that. He did not like that idea. And he decided that the best way to prevent that from happening would be to simply stop working on the models. And that's what he did. He stopped working on the YOLO models, but he left his work open source on GitHub under the pjready/darknet repository. And this is what allowed me to come over and see what was going on in the computer vision space. And when I did, I saw that this YOLO V3 model was really the best. And this is what I began with to not reinvent the wheel. So Ali Farhadi went off to create a startup, which was called xnor.ai. He ended up selling that to Apple, where he was until recently. He's just left, and he's now at the Allen Institute for Technology working on LLMs. So since these two had split ways for different reasons, the community was no longer going to see new versions of YOLO. But somebody called Alexei B showed up. He was living in Moscow at the time, I think more recently in Berlin. And he was very good with C, which is what Joseph wrote Darknet in. And so he didn't just create the YOLO models, but he created a training framework that was called Darknet, which is much more complicated than just creating a model, of course, because you need things like an optimizer, loss functions, and so on. So Alexei forked the pjready/darknet repo. Then we had Alexei AB/darknet, and he continued to maintain it and improve it. I had no idea how to use C, so I started from scratch with Python, which was much more familiar to me. And I built up a new model that reproduced identically, essentially, the performance of Joseph's work. It took me a long time. It took me over a year just to get to a point where I could reproduce it in Python, and about another year to get to a point where I had sufficiently improved it to be able to launch a new architecture. But in the meantime, I collaborated with Alexei, and when he released the YOLO V4 in 2020, I baked those lessons learned from his advancements into my release a few months later. And so there was a lot of controversy in the academic space, especially since neither Alexei nor myself were original co-authors on the first 3 papers. But I tended to ignore the criticism and do what I did best, which was simply keep working on YOLO. So the architectures themselves got more and more popular, and I think this was due to their simplicity. So many other competing architectures had evolved in the space, like over the intervening years, but the YOLO models kept their appeal, and in 2022, we saw a Chinese company, Meituan, release their own flavor of YOLO, which is called YOLO V6. This was very performant, and it was a quite impressive release. And shortly after, Alexei and another researcher called Wang Qinyu, who is in Taiwan, released a new version called YOLO V7, which was built on advancements including YOLO V5 and YOLO V6. So at this point, YOLO V5 had had quite a long run. It had been out for 2 years. And we update it quite often, daily almost at that point. But it was really time for some breaking changes, because when I first started working on YOLO V5, I could change anything I wanted, and there was no problems. But 2 years later, it had a very large user base, which meant that my freedom to operate was very restricted, because if I changed something, 10 people the next day would show up and say, hey, all my workflows are broken, what did you do? And so we had a lot of improvements that the team wanted to do, but we couldn't change many crucial aspects of YOLO, like for example, like the workflow, the training commands, and things like that. And so we were accumulating those, and we also factored in the advancements from YOLO V6, V7, and other architectures, such as RTM-det, YOLO Gold, and so on. And we created YOLO V8 with those in 2023, about a little over a year ago. So the main work was by 3 contributors, which was myself, Ayush, who would come on from Weights and Biases, which is another AI startup based in San Francisco, and Jing Qiu, who's here in China, in Chengdu. So we launched this last year, and we've been steadily improving upon it. So we release patch updates, as they're known, almost on a daily basis, with features and bug fixes. We try to do minor updates on a quarterly basis, and we are staying ahead here of some of the competition, and we're going to release an updated version later on this year at our YOLO Vision event, which is an annual thing we do on September 27th every year. This year it's going to be in Madrid as a hybrid event in conjunction with Google Campus. So, okay, about the models themselves. Now that they've been out for a while, we can take a look back and we can see just the tremendous usage and the adoption by the community, which is really exciting. So these days, our website and our GitHub repositories receive over 5 million monthly visits from people all around the world. And we picked up 80,000 GitHub stars over the last few years, which is just very impressive. When I started this about 5 years ago, I had never used GitHub, never done open source. I'd never even used Python or AI. So I think a lot of the advancement here really comes from, I think, the outsider perspective, and my main perspective was to try and simplify things. That was my #1 priority, was to make things simple. Because when I showed up, there was a lot of activity in the space, but it was all very confusing and very hard to get started with, which gave me a lot of headaches, and so I tried to simplify things for myself. But since everything was open source, everybody else enjoyed it too. So we also have analytics, and we can see that every day people are training more than 2 million YOLO V8 models now around the world with our Python package. And then they're using those models over 300 million times every day. So in about 30 minutes, by the time this little talk's over, we'll have about 10 million usages of YOLO all around the world. And a usage we just count as somebody running it. But they could run it on a video, for example, and process thousands of images. So the actual number of images analyzed every day is surely in the billions. Oh, and the best part is we've done all this fully bootstrapped. Bootstrap just means that we've never raised money from investors. So we've gone very efficient and done this the hard way. So we've been very careful with how we spend money, and I think a big community contribution also is responsible for this. So as an open source work, the YOLO repos now have over 500 contributors all around the world. And we're super grateful to them, and they've been a big wind in our sails to be able to power all of this growth, especially without having to take money from some of the large investors out there, like a lot of our competitors. Oh, yeah, okay, so speaking of competitors, the AI space is really interesting. It's rapidly evolving, constantly changing. In the computer vision space in particular, we look at different large companies, companies like Meta with Detectron. I can't read this, but many other companies like Apple, Amazon, and here in China, Tencent, Baidu, and so on, and startups. And these are companies like RoboFlow, Comet, Labelbox, Deci, which NVIDIA just bought, that has their own YOLO NAS models. And what we measure is GitHub stars to compare popularity, and then downloads per month. And we can see that the models that we have are just very popular within the community. And I think I really personally attribute that to the simplicity. If something's really complicated, if you're comparing different products, which we always tell people to do, if you have a new AI project, you should always try a few different solutions. If one of the solutions is just much simpler to start with, and you get results right away, whereas after like a few days, you're still struggling with the other two, you're probably just gonna go with the first one. So this is why I think the popularity is here. The performance also, but I think the focus is really on just having everybody use these. And we see that, for example, like when we see school kids, like high school kids, using YOLO within their projects. We even sometimes on GitHub get questions that start with a sentence like, hey, I've never used Python before, but I just trained a YOLO V8 model, and I have a question about the output format. So people that have just never done things before are training these models and using them. Okay, so the emphasis here on the models is twofold. So we want accuracy and we want speed, but we also want to make them small. And you can imagine these are three arrows just pointing in different directions, and it's a bit of a tug of war. So in any kind of design situation, what you end up with is a compromise between competing interests. And what we see ourselves as the architects of the models is sort of the deciders for what we're going to focus on, what we're going to prioritize. But I think what we have is the right combination. And I think when you look at a lot of the best products in the world, the most popular products, they may not be the fastest. They may not be the ones with the largest displays. For example, an iPhone doesn't have the most memory. A Tesla Model 3 doesn't have the most range. It's not the fastest. But it's got the best compromise among all the competing interests that people tend to like. And we've really focused on that. The architecture itself for YOLO V8 includes a number of advancements that we've put in. Half of the R&D, I think, comes internally from myself and also from JinQ. We have burned through cloud credits at all the major cloud providers like Amazon and Google. And we've recently purchased an A100 server to power some of this. But what we do essentially is we take a look at any of the modules, we try and change something, and then we obviously track this with a system like Weights and Biases or Ultralytics Hub so that we can compare hundreds of iterations. If you change something in one direction, like the number of repeats in a layer, and your model worsens, that's still a good result because you know that if you go in the opposite direction, you'll probably improve. So over hundreds of iterations here, we tend to get improvements on the architecture side and the same thing on the hyperparameter side. And of course, we combine that with advancements that we've seen in other architectures to get the models that we produce on an annual or biannual basis. Okay. One thing that's really important at Ultralytics is helping people use the models where they want to. So I really like YOLO because you don't need to use it in the cloud. So this is not like Anthropic or OpenAI where you have to send a picture somewhere and then they do something to it and send you a result. Here you have the model, you run it yourself. You're gonna run it as many times as you want. You don't have to pay anybody. And depending on where you're gonna run it, you're probably gonna want a different type of format. And we've tried super hard to support every possible format out there. And I think these days there's 13 different formats. If anything's missing, let us know and we'll try and add this. But they include, of course, PyTorch, which is how you natively train the models, TorchScript, Onyx, OpenVINO by Intel, TensorRT, of course, by NVIDIA, Apple's CoreML, TensorFlow, TensorFlow GraphDef, TF-Lite, Edge TPUs, JavaScript for the browser, Paddle, and also NCNN by Tencent, which is surprisingly performant on edge devices. So we test all of these on a 24-hour schedule in the repository, so you can see exactly how fast each of these are and what the accuracy loss is, if any, on the different types of GitHub runners that we have in the different operating systems. So we are obsessed with CI, testing, continuous integration, to make sure that everything works all the time. So when you go to the Ultralytics, working correctly. And if anything fails, we try and address it immediately. We treat it really as an emergency. So, okay, we've also started getting better documentation. So with YOLO V8, I worked really hard on the models, but I didn't document anything. And people come up to me and they say, Glenn, how do I use this? And I say, I'm sorry, I don't have time. I need to keep developing them. But we learned the lesson, and we've created about 300 pages here of documentation, including the different tasks that we support, like detection, segmentation, different modes, like training, prediction, validation, export. And we also started supplying data sets to help people get started. Because, of course, without a data set, it's difficult to train a model. So we support about 20 official data sets now for the different tasks. For example, COCO for detection, DOTA for oriented bounding boxes, and many others. So, and these are all automatically downloaded the first time you try and use them. So if you want to train, for example, a YOLO model on COCO, you don't need to have COCO, you don't need to have the YOLO model, you don't need anything except pip install Ultralytics, YOLO train. And then it'll download COCO dataset, it'll download any pre-trained models it needs, and it'll just start training. So we've tried to make the whole process very simple, including automatic download of anything that's missing, even including automatic installation of any packages that are missing. Cool, okay, so, all right, so benchmarking here is something that we do, and this is benchmarking here on A100s for TensorRT, but also on Onyx format for CPU. So if you're running models on CPU, the typical places that you want to export to are Onyx by Microsoft, but if you have an Intel CPU, OpenVINO is probably going to be faster. If you're running a Jetson or any type of NVIDIA hardware, TensorRT is the default destination. For edge devices, the picture is much more cloudy. An interesting story is actually for our Android app. TF-Lite is the models that we have in place right now, but NCNN models exported through the Ultralytics package are actually comparable, if not better, for many tasks. So what you want on these plots is for your model to be in the top left. You want the model to be fast and accurate. And of course, you want the size to be small also. So we've got different plots here that compares to previous architectures, and when we release our new models in September, we're going to release additional plots with a lot of the competitors that are missing also. Okay, the different tasks. So this is really cool. When I started YOLO, it was just an object detection model. So it just did detection. That's it. And there were specialized models that did other things like segmentation, classification, like ResNet 50, obviously, pose estimation, oriented bounding boxes. And what we've done now is we've created a single unified backbone in YOLO V8, and we've trained it with different heads, which have different numbers of output vector features and also different loss functions and different data sets. The result is now that we have a single unified YOLO V8 model that is capable of training different tasks. So the model checkpoints are different. You can't do all of this with a single model, but they have 90% commonality in terms of their architecture. This means that when we train the next generation of models, we'll be able to train all of these tasks, and they will all benefit from those improvements in the backbone. So to explain a bit, segmentation, it seems to be much more useful than object detection. The downside is that the annotation burden is much higher. It takes you much more time to label a data set this way. Though interestingly enough, a lot of that is changing with the advent of things like SAM by Meta that allows for much faster annotation of these types of data sets. Classification is where the whole computer vision space initially got started and became famous with CNNs with the advent of ResNet primarily. So pose estimation is a really cool application. You can do this for people, but you can also do this for animals. It turns out a lot of the YOLO users are doing pose estimation for agricultural applications, things like cows. And the purpose for that is, for example, if a cow doesn't ever raise his head above the horizon, it's an indicator that he's sick. And then they can call a vet to go attend to that animal. And this, of course, has to be combined with tracking, because if you don't know which cow is sick, you don't know who to attend to. So the agricultural applications include tracking combined with pose, which we make really seamless. So to track an object in the video instead of predict it, you would just run a YOLO track command instead of a YOLO predict command. And the tracking is available with 2 state-of-the-art algorithms that are parameterized, and you can change those values also. So tracking is seamlessly integrated into detect, segment, pose, and OBB models. So it's really cool. Oh, and the last one is OBB. So this looks really similar to detect, but it took us like a long time to get this out. The advantage here, obviously, is that you can track objects that are stacked next to each other, like ships in a harbor, and it's most suited to rotationally invariant domains, such as satellite imagery or medical applications. We're working on additional tasks, too, and as I was talking to Elaine about this, we're going to add facial recognition and action detection to this year, and possibly depth detection, too. So we're going to have a nice family of tasks that are all fed in by the same backbone. Okay, and here's a preview of some of these tasks. This is, as I was mentioning, satellite imagery with oriented bounding boxes. And once this finishes loading, we're going to see the camera rotate, and you can see that the boxes themselves are also rotating with the camera. And this is another type of application. You can see the vehicles that are tilted, and the boxes tilt with them. So the number of applications we get is almost unlimited. But I'd say that the most common types are in manufacturing and retail. So we also have examples of pose estimation, which is really useful for things like video games and fitness apps. And of course, instance segmentation, which is really useful for manufacturing settings and other places where bounding boxes may not sufficiently accurately track something. And here you can see an example of segmentation with tracking. Each of these here has a track ID that's followed. So there's a tremendous amount of applications here. I think one of the most complicated things at Ultralytics is explaining to people what YOLO does, because it does so many things. And it makes me super happy because we're having such an impact on so many different aspects of society and so many different domains in business and in industry. So I think we are here at Ultralytics really well placed to drive forward the future of YOLO. And I think the number one reason is really the community that we've built up. So we can't take credit for all of this ourselves. Ultralytics is just about 20 people, we're really small. But we have thousands and thousands of people in the community that give us feedback about what we could do better, what's gone wrong when they use YOLO. And of course, hundreds of those people that are actively submitting pull requests and helping improve the technology day to day. So I think the future is really exciting, and I'm really looking forward to executing on this over the next few years. So we've got a QR code here. I don't think this is going to scan for you, but we've got a really cool app on the App Store and in Google Play, which you can preview this right there. If you can't scan this, which you probably can't, you can just search for Ultralytics YOLO or Ultralytics Hub, and you can check it out right in your hand. So that's it, guys. I guess I should see if anyone has any questions. Yeah? Yeah.
First, I want to thank you for the YOLO series, and we all benefit from it here. And my question is, how can you define the high quality data as garbage in, garbage out?
Yeah, yeah, okay, so.
Automatically select the high quality data, and what's your opinion on using negative data for training, maybe like trace object detection, something like that?
Yeah, this is a good question. It's a really interesting topic because there's no such thing as high quality data. Like traditionally speaking, you would think that if your pictures are clearer and the bounding boxes are better, you're going to get better results. But you're only going to get better results in those kind of domains that you're training on. So what you want to think of is essentially that whatever you're showing the model is what it's going to return back to you. So if you want a model that operates well in, say, days where it's really cloudy or where the camera is blurry or where the lighting conditions aren't very good, then those are the pictures that you actually want to show it. If you just show it like very clear and very accurate pictures, it's only going to be capable of operating in those kinds of environments. So the most important thing is you have this, imagine you have like an image space, which is like this slide. And you want the training data to be sampled from the image space. But you also want the domain that you're going to deploy it to also be sampling from the same shared image space. So if your deployment environment is high quality, then you need the training data to be high quality. But if the deployment environment is low quality, like maybe you have like a very cheap camera, or maybe you're always deploying it in places where you're trying to see things far away, or the camera's upside down, or it's got dirt on it, then the training data should have pictures with dirt on it also. That's the most important thing. And for the labels, oftentimes I get asked also, like, should we put the box exactly like this? Like, what if an object is off the screen? What do we do? And it's really, really simple. You don't have to think about any of those things. The only thing you think of is that the examples that you show it during training are what it's going to learn. So if you, for example, you could annotate it with boxes that are like 50% off, and then it's just going to estimate boxes like that. So that's what you should keep in mind, is that however you label the data is how it's going to predict that over here. So when you think of how do you want to label the data, what you should think of is how do I want my predictions to look, and then just label the data like that. So, yeah. Okay, anybody else? Yeah, yeah.
I got a question about the track map. So for the agriculture scenario.
Yeah, yeah.
So I would like to know for the track ID, is it kind of a predefined, kind of you have to pre-input the kind of the feature of the cow, and then you give it an ID, or it's kind of a quick scan and then it has the unique features and get it, and then you have to track the ID and then.
Yeah. Okay, so so the cow tracking, like I really love this example. This company that implemented it, they came back and they showed us a demo, and they're like, Glenn, we got a big problem here because we start the day and there's like 20 cows in the field, and the track IDs go from like 1 to 20. And they're like, all right, everything's good. But then after 8 hours, they like show us, and the track IDs have gone to like 160 to like 180. And they're like, but there's only 20, something's obviously wrong. And of course, what's happening is that the tracks are dropping and they're not getting re-ID'd as the same cow. And so it's getting assigned a new track. And this will happen, for example, if I'm a cow and I walk behind the screen, I pop out the other side, then the tracking algorithm will say, oh, it's a new cow, and it'll assign me like a new track ID. So we have something called re-ID embedded in the trackers. And we didn't create the trackers. The trackers are two SOTA trackers that are byte tracker and bot sort. And there's a few candidates that we can add for improved trackers. But again, like the idea is that we don't want to reinvent the wheel on tracking. We'd like to take the best there is and seamlessly integrate it. But on re-ID, what this commercial client did was they actually implemented facial recognition for cows. And so, well, yeah, so apparently like cows have very unique faces. And they built up a database of facial recognition for each cow. And then when they initiated a new track, before initiating a new track, they would compare the feature of the cow's face, the feature vector, an embedding, if you will, to the 20 embeddings that they have, and they would make sure that it wasn't already existing in the database. And that worked much better. So,
what if it's the bad, facing the camera, and then, how you identify, oh, it is the track ID, it has problems sending it?
Yeah, well, okay, so, there's textbook examples that you learn in school, and then there's the real world, and this is one of those cases. So, so they're, this is not a solid problem actually, and that's why they're coming back to us, because they were struggling with it a little bit. But that's an excellent question. Like if I'm a cow and I'm wearing a jacket, and then I go behind the screen, I take my jacket off, am I going to get re-identified as the same person? I think there's additional ways to improve re-ID. There's no free lunch, so any additional methods that you apply come at additional compute. But I think in this case, it might make sense. This particular case, it might make sense to apply the same facial recognition to the different sides of the animal. So just like you said. So facial recognition isn't really unique to the face. Like all it is basically kind of landmark identification, rectification, and then an embedding extraction for that object. And that could be any part of your body. So if you have, say, the animal broken down to like 10 or 20 sides, you could, instead of having 20 faces, you could have 20 by 20, like 400 parts of the animals, and see if like any of those correspond. But again, that's not going to be like a full solution either. So.
But probably because of the AI process, this kind of will simplify the process to define the ID. Because it's easier to have the 3D scanning features for each unique.
Oh, they also, well, that was another interesting thing that they did. So they had three-dimensional detection. So they had, for example, 3 posts set up with 3 cameras, and so they knew each camera transformation matrix, and so they could identify a vector in 3D space for each animal. And that greatly improved the re-identification. Because the re-identification, it can be based on multiple things, and one of them could be, say, a Kalman filter for the direction the animal is walking. So if I'm walking this slow and I go behind the screen, but then I'm walking the same speed, and the Kalman filter is saying, okay, Glenn has a covariance matrix for where he might be, then, oh, okay, this is a person it's inside this probability for where Glenn was last walking. So you can combine like multiple different things to assist in that. But there's no like single magical solution. And in any different domain, it's going to be slightly different set of problems. So like cows are not going to change their clothes and put a hat on, but people might. So.
Sorry, I got a second question.
Yeah.
It's about YOLO work.
Oh, yeah. Yeah. Yeah, I should, okay, yeah.
Because I'm not that technical, so actually I'm not quite understand. So after the launch of YOLO work, then how is it? No advanced, but it's just I feel. May I ask about the other YOLO model?
Yeah, so okay, YOLO World is a combination of a YOLO V8 backbone with a transformer head that's been trained on text embeddings matching with images. And so the end result is it's essentially a zero-shot promptable model that you can specify which classes you want to detect. So in theory, it sounds amazing. It means that you wouldn't need to train anything, right? In practice, it works, but you're not going to get the same result as if you actually trained on those specific classes. And of course, it's only going to be knowledgeable about classes that are common, like in the world as you see it. So, for example, manufacturing is a big use case. And the use case is if you're making a widget, there might be some damage on it in the assembly line, and you want to eject that before it gets to the store. And the damage in your widget is going to be unique to your industry. And so a YOLO world style model is never going to work there. But if you want to see somebody with green pants and a blue shirt, you can say that. So the way it works, I don't know if this is connected to the internet. Let me see. Okay, so if you go to docs. Oh my goodness. Okay, well, all right, so if you go to docs.ultralytics.com, we have a YOLO world page that explains how to use it. Yeah, and it's super simple. So I'm gonna pull up this like little text snippet because you can try it too. And for example, if you say I want to see a girl with a yellow shirt, it'll probably work really well. But if you start to get a little more specific, like then chances are, or if you start to introduce like many classes, then the accuracy is not quite there. But it's also just, this is the first time that this has been released. So I'd imagine it's going to improve in the future. Yeah, all right, so if you click on these, and then, okay, so if you click on models here. Okay, so we support all these different models that you see here, and at the bottom, well actually let me explain these. So we have all the YOLO versions, and then SAM by Meta, Mobile SAM, and Fast SAM, which are faster versions. YOLO NAS by Deci, RT Deader by Baidu, and then YOLO World here. And so if you click on YOLO World, we've got a nice YouTube example here, and then we've got some code examples right here. Yep. Let's see. Actually, yeah. Okay, this is what I'm looking for. Okay, so yeah, I think can you guys maybe can you make this a little bigger? Like Control plus. Yeah, perfect. Okay, so this is really cool because, how does this work? Yeah, okay, so you just pip install the Ultralytics package and then you import YOLO. And then instead of loading a normal YOLO world model, you load a dash world model. So this one is YOLO V8 S dash world. And then you have this model instance defined. And if you don't define classes for it, it'll just detect Coco objects, like dogs and cats. But here we can set classes. And so I don't know why in this example we're setting the same classes it already knows, but maybe there's, that's kind of beside the point. But what you would do here is you would say any class you want. So you'd say person with yellow shirt. And this is going to embed these classes. So this takes a little bit of processing power. You don't want to run it like every frame. But you run this once offline. And then you can save this model, and then it's just like any other normal YOLO model, except that it's only going to detect people with yellow shirts when you load it and when you run it. So let me see if, yeah, here you go. And the usage is exactly the same. So this is really cool, and like in theory, like you look at this and you're like, wow, I never need to train another model again. That's the idea. It's not quite there. It's probably going to take a little more time for it to kind of catch up in reality. But we've tested this, and you can see that it works really well in some of the examples. I don't know if we have a picture here, but I wrote a Medium article, and I had a picture of a bunch of campers, and I said, show me the water bottle and shoes and like a blue t-shirt, and it detected all of them correctly. So for some applications, it's very powerful. And I think it's a good indicator for kind of the overlap we're waiting to see with language models and vision models. And I think there's a lot of exciting R&D going to happen there in the future. Yeah.
Yeah, please explain one of your most frequent exploding scenario or use case of your model.
Most interesting?
Yeah.
Oh, okay, yeah. Okay, so if you ever go to Denmark and you're in Copenhagen, if you rent a boat and you take it the wrong way into the harbor, you're going to get a ticket. And that's because the city of Copenhagen has YOLO models running in cameras looking at the harbor. And apparently, like, boats going the wrong way, I guess there's like rights of way and like naval navigation. And it used to be a problem, supposedly, for boats going the wrong way, and now they're automating the process for identifying when that happens. So, yeah. Paolo, are there any other ones we could? So there's the cow re-ID. Yeah, there's package tracking. Yeah, so if you got a package in Europe, like over the winter, there's chances from Amazon. There's chances that it was followed by a YOLO model for the tracking to make sure that it got to where it's supposed to go in the distribution facilities. So.
So how about the most power-hungry one?
The power-hungry one? Well, no, the idea is that all of these are relatively light. But power-hungry is definitely on the training side. The training, so the A100 and the H100 servers, these use up to like 4 kilowatts during your training. So the most power-hungry part of the process is things like hyperparameter tuning. So hyperparameter tuning is simply training a model many times, changing the hyperparameters slightly each time, and then evolving those. And it's a semi-automated process, and it works well to improve the accuracy on your data set and in your domain. But it takes a lot of compute because it's essentially training hundreds of times. So the idea is you train hundreds of models to get those hyperparameters. And then once you get them, you just train one model, and that's more accurate. But that takes a lot of time and a lot of processing. So unfortunately, AI in general is very power hungry. So it's not the greenest technology, but hopefully as power generation continues to progress into more green, like especially here in China, I think the rate of solar and wind generation is amazing, and it's increasing every year. So if that turns green, then the AI burden there is going to be not so consequential, I think. Okay. Oh, maybe we should get this guy first.
All the things seems to be the camera are fixed. If the camera are moving around, I'm trying to apply some another technologies like virtual automation into the YOLO model.
Like what into YOLO?
Virtual automation.
Range?
Into more.
Yeah. So I think the question was about like moving cameras and I guess combining like more information extraction. So before I did AI, I was still doing cameras, but I was doing something called photogrammetry. And there's an application called structure from motion, which is if you have a single camera or multiple cameras and they're moving, it's a closed, essentially, solution to solve for those cameras and the objects that they're seeing. And there's a number of different ways to do that. I think some of the interesting overlap is in depth models. So some companies like Tesla, for example, have taken a really hard stance on technologies like LiDAR for self-driving vehicles. They say it's not necessary, but they still want those depth maps. And they do that through what they call pseudo-LiDAR, which is really an estimation of depth based on AI models that are trained on actual LiDAR data. So that's sort of like an AI version of structure for motion, in that an AI model is doing the same thing that we used to do with a classical solution, structure for motion. So there is overlap there, and I think it would be really exciting for me to finally get these depth models out. Because for me, I think it would kind of loop back into my original work there on structure for motion. So, and I think also on three-dimensional detection is something that we're missing here. We've talked to robotics companies, and obviously depth detection and object detection for three-dimensional data is a much more relevant application than just detection without any depth. And so we have work to do there also, separately. So hopefully we can bring that in and add that as an additional task, which would be three-dimensional object detection. Okay, yeah?
I was asking, what's your thought about
Oh, yeah. Yeah, yeah. Yeah. Yeah, this is really interesting. These days, well, you could always simulate data. The quality of the simulation has been improving, but simulations have always been there. And there's some companies that have sprung up that specifically specialize in that. So if you want, say, people in different scenarios, like at an airport, they can simulate that. And these days, there's gaming engines like Unreal Engine that can do that, like astonishingly real, with different lighting conditions and ray tracing and so on. And more recently now, we have generative AI that can actually create those images, which is really interesting. And so we've actually experimented a bit with that. I don't know, it really depends on the application. I think one thing that we have in mind is for our Ultralytics hub is that we want to make it easier for people to train a model. To train a model, you need data. And we've been looking at all the different ways that you can source data or generate data. And generative data applications are one of those. I think it depends, on the domain again. Like, I don't think they're going to be able to generate data for specialized like production applications like defect detection on the parts that you're making. But if the domain is broadly general, like if you just need people and animals, then I think it's starting to become like a valid source of data. Of course, it doesn't come with the labels, so you need to be creative in how you apply it. But for example, if you're looking for their agricultural data set of cows from different angles, I think generating that data and then annotating that with a model that's already trained for those boxes like YOLO, I think is definitely a smart way to possibly generate some of that data. The real answer though for like any specific domain is it's impossible to tell unless you actually try it. So I always tell people ML is an empirical science, which means that the answer that you get from an experiment is the right answer. And like every other answer, like people's opinions, what you think, what theory says, doesn't really matter. It's really what the experimental result is. So there's no substitute for trying it. So in your case, like I would try it, see how it works, and if the results are suitable for your application, then I think you've got your answer, and then you can go ahead and keep doing that. Yeah. Yeah, when I started doing YOLO, I experimented thousands of times. So like every day I would wake up, try things, and like 95% of the time they would be failures. Like they wouldn't work, or they would break things, or I'd train a model and it would perform worse. And the only way that I learned was just by running more and more and more experiments. So most of those are going to be failures. Like there's no kind of industry these days where you're going to wake up and just try something and it's going to work better than what you had before. Like, or if you do, that's pretty lucky. And then the next few times you try it, it's going to work worse. So it's really a lot of trial and error, just a lot of effort, and a bit of creativity too to come up with those experiments. Yeah. Yeah. So I think the question was like how YOLO and language models like relate, if at all, and like where I see that going. So we had a plot before of the performance of YOLO models for like speed and accuracy, and a lot of people, they ask things like Glenn, what about ChatGPT? It's got a vision component now. Is it gonna like eat Ultralytics lunch and you guys are gonna go out of business? But the answer is that they exist in completely different spaces. So ChatGPT and large language models like it, like Llama, for example, and Lava, are much larger and much slower. And the typical application that we have for YOLO here is something that's less robust, which means it can do less things. Like it's not going to write you a poem, but the things that it does do, it's extremely fast. And the market for these two different things doesn't have significant overlap. So this is sort of like a bicycle, and maybe like an LLM here might be something like a truck. It can carry a lot of things, it's really expensive, it can move a lot of stuff. But some people just need to get from A to B, and they don't want to buy a truck. They don't want to spend that much money. So there's, I think, a place for like more refined, more specialized models. And there's also, of course, like as we've seen, an enormous market for very generalized models that can do almost everything. But just as like I would not, for example, if I wanted to say go to the doctor, like I wouldn't go to a doctor that was also like a PhD in economics and a lawyer at the same time, like all these different things, because that would be really expensive. I would just go to basically what I need to get the job done, especially if I'm a business and I'm concerned about cost. So I think they're going to be separate, but I think there's of course a space between these that's connected by a line with increasing complexity, increasing cost. And I think there's enough market space for a wide range of companies and models to exist between companies like OpenAI and Ultralytics. So, and this is the real interesting startup space that we see with so many companies popping up, so many solutions, and so many things changing these days. So it's an exciting space to be in. Okay. Yeah.
I'm David from Center Media Group.
Okay.
I have used YOLO in some sports events,
Okay.
like World Cup, 2022.
Oh, wow. Okay.
And I have a problem working with YOLO. It's like sometimes we need to maintain the speed for detecting and tracking the right person. But for the top level event, and we are not allowed to use some like facial data to recognize the right person or the right coach. That's not allowed, as they told us. So I was thinking about if we have another way, or how do we think out of the box that we can track and detect the right person without using their facial data.
Oh, yeah. Yeah, there's different techniques. So the question is if you want to track a person in a video in a field with multiple people. Yeah, like in live events, yeah. So there's, without any kind of, like if his face is blurred, then there's different solutions that may work there. So one of them is about gait. So people walk with different gaits, apparently. I haven't done work personally in this, but I've seen other researchers look into this. And so you can actually, if you have a pose estimation model, you can see how people are walking, and you can create like a feature vector from someone's gait over time. And you could use that to identify a person. So just like the facial recognition is essentially an embedding vector from the face, you could get an embedding vector from the points in the body and possibly match that up. But of course, the clothing itself, I think, is something else. So if it's short-term re-identification, like the same person dressed in the same clothing going behind a scene, you should be able to pick them up even if their face is blurred. But for long-term identification of the same person, I think gait is possibly like the only way that I can think of right now. So.
I heard about that you discussed something like you can track it, like you can say that the coach with the white, maybe the red tie or the blue ties. But
yeah.
what do you do in the real time if I just saw that he wear a red tie? Can I use it directly?
Yeah. So part of the challenge is we can do tracking. So tracking is embedded here in the Python package, but oftentimes you're going to deploy your model to something else. Like maybe you're going to run it on an embedded ASIC or something like that, and then maybe the model is going to be in a format like JavaScript, where we don't have access to the Python. And then at that point, then the tracking solution, you have to create that yourself or source that from somewhere else. So once the model leaves the Python environment, then you can't use the Ultralytics Python package anymore, and then you can't use the embedded tracking solutions. So it's a bit of a challenge, but it also depends on, I guess, the resources you want to put into the program and so on. So, yeah, I think tracking is really interesting also because it's a way to auto-annotate data really simply. So if you have a video and you have a bounding box for a prediction, then you can track that also, and you can see where the bounding box for the track is and where the bounding box for the prediction is. And if you have, for example, a frame where nothing is detected, but the tracking box is propagated, then you can use that frame. You can say, oh wow, this is a failure mode for the model. Let me save this image. Let me auto annotate this with the tracking box and put it back into the data set and retrain. So tracking is extremely useful for iteratively improving your data set and then retraining the models.
According to the cameraman's habit, maybe for the regular camera, we put the person in the center. So we have tried that. We use the biggest bounding box in the area, but sometimes the coach will they are very.
Oh, the camera moves a lot. Yeah. Oh, yeah.
They will tracking maybe the assistant coach.
Yeah. Okay.
And we have used for human assist. You can click to really track the right person.
Okay. Yeah. I think one thing that you might get, for example, in a zoom camera, you might get a lot of, like the wind, for example, might shake it. And sometimes what happens is like the image that the camera snaps is really blurry. Like if the camera's moving a lot, like instead of me looking like me, I'll just look like a blur. And sometimes what happens is when models are trained, they're trained on people with no blur. And this goes back to the other question. So like if the camera is like moving around a lot, then you probably want to go back to your data set and make sure that you have people that are annotated and they look blurry. Of course, like auto blur, like on a horizontal dimension, I think is something that you can put in as a hyperparameter for your training. We don't have that built in, but we have albumentations supported, and I think that's in there. So artificially blurring, like horizontal motion and vertical motion.
There is a lot of challenge for the live broadcasting.
Yeah.
Yeah.
There's a set of default hyperparameters that are going to augment your data. They're going to make it like they're going to rotate it slightly, zoom it in, zoom it out, but we don't blur it. We try and create a default set of hyperparameters that are going to be suitable for most use cases. If we add too many augmentations like blur, and people don't use blurred domain data, then they're actually going to get worse results. But if the domain is blurry, then you're going to get better results. So that's like we kind of create these default models that are a middle ground to compromise, like I was saying before. But if you're experiencing things like that, then you definitely want to go back to your training data and see if you can artificially blur it. Even if you're starting with something like Coco, you can still just add the training hyperparameters to blur it horizontally.
I think YOLO is very suitable for the live broadcasting. They are real time, and YOLO is real time.
Yeah. Okay. All right. Thank you, guys. Yeah. Okay. Oh. Yeah.
I'm Jason. I'm from Toy. I'm robotics company.
Okay.
I want to ask a very simple question. Is there a pre-feed module for recognize all kinds of sports like volleyball, basketball, ping pong?
You know, and now that you say that, there probably should be, because there's only like a few set of sports that are really popular. But no, we don't have sports pre-trained models. We've got Coco pre-trained models for detection, segmentation, and pose. We've got Dota pre-trained models for oriented bounding boxes. And then we've also got OpenImage's V7 models, which is our biggest data set. It's got 650 classes, and it's by Google. And that's only for detection. So we don't have sports-specific pre-trained models. So. We can, we can take a note of this to add it to the roadmap. We've got a long roadmap of things we need to add. So, but saying that, you know, you can use the Coco models or the OpenImage's V7 models out of the box on sports imagery. So, for example, in a basketball game, it'll see the players and the ball. This is a class called sports ball. And for OpenImage's V7, it'll get things like their faces and their hands and their feet. So.
How long to train to recognize this force to train a module? How long?
How long to what?
To train a
Oh, to train. Oh, yeah, yeah. So, yeah, so training, training doesn't take that long. Like if you have, say, 100,000 images, it might take a day, maybe 2 days. But what takes a long time is getting those images and annotating them with the labels, like the bounding boxes. That's the longest kind of like human effort part of the whole process. So.
I think there is another way, like we can use the YOLO word to auto-label all kinds of.
Oh, that's true. Yeah, that's a good point, Elaine. Yeah.
We have a try. Okay, so thank you everyone. So I think I want to add on something. So Ultralytics recently have got huge great work on their documentations, including all the models, and also you add YOLO word, the SAM segment, anything, and also we have our NVIDIA Jetson series, and from Jetson Nano and to the Jetson Orange, support all of YOLO V8 models. All kinds of the all sides of the YOLO V8 models, and besides, we have the benchmark. So, for example, for a retail space or any video analytics solutions, we have the benchmark of using one YOLO V8 model, like how many streams it can take using one Jetson Orange device. So that is the answer is from the 8 streams to 18 streams. Yeah, so welcome to check the documentation, and I think we've provided step-by-step tutorial to make sure everyone can run the YOLO. And besides, our engineers also working on using one line to deploy all the YOLO models, one line code. And furthermore, we have like we have the Jetson example, the GitHub repository. So without any code, you can run, including the YOLO models and large language models. So we will share with everyone soon. So stay with us. So, but Glenn, so what is your next event?
Oh, let's see here. Well, we've got our really big annual event every year, September 27th. So it's going to be live stream on YouTube, and I think Billy this year should be the first time for us. They'll be live in Madrid too. If you want to take a flight out, we'll be there. And yeah, between now and then, we've got a few trade shows we're doing also. But that's our big Ultralytics event.
That's great. All right, thank you, Glenn.
Yeah, thank you, Elaine.
So we also have time to give everyone to free chat with the team. Oh yes, let's take a photo.